Hello, my name is Rohan, and this is a presentation on security audit on library management system. So basically, why do we need application security? Given the rise in digital technology and revolution, like most of the web developers are concerned with the application making it user friendly, but least focus is given on the security measures and the threats and vulnerability revolving around it. Uh, in order to address um, in order to address the security issues, we need to look at programming paradigms and their evolution from machine code language till machine learning. So basically, it is as we can see, the abstraction of the hardware is being increased, and with each iteration of the generation of programming paradigms, it is observed that high level of languages are being used, and it has reached to the point where these instructions are no longer being given by the humans, but in the part of machine learning, which is the latest paradigm, these instructions are not humanly possible to be given. Instead, these are compiled by the computer itself in order to make this learning. Um, so talking about programming paradigms. What is programming paradigms? Programming paradigms are basically the approach in solving programming. Basically the approach in which problems are being solved. So it has two types: declarative and imperative. Declarative programming, it talks about um, logic of computation, which describes its control flow, while in imperative programming, it uses statements that can change the state of programs. Declarative, it has two types: functional and logic. In functional, we express computations as evaluation of mathematical functions, while in logic, we express computations in terms of mathematical logic. In imperative programming, we have two types: procedural and object-oriented. In procedural, we talk about the concept of procedural calls, in which statements are structured in procedures, while in object-oriented, programming is based on the concepts of objects, which can contain data in the form of fields, code, and in form of procedures. Moving on, so why do we like Java has become more popular, and uh, talking about C, C++, Kotlin, like Java is more popular given its write once and run anywhere attribute. Also its robustness and many other features. So Java is built on four pillars, basically: encapsulation, abstraction, inheritance, and polymerization. So when we talk about encapsulation, it is the process of bundling data and operations on the data together in an entity, while abstraction is the process of exposing the essential details in an entity while ignoring the irrelevant details. Inheritance is used to derive a new type of form and existing type, thereby establishing parent-child relationship, while polymerization lets an entity take on different meaning in different contexts. So software development life cycle. So in order to develop software securely, we need to integrate security in each and every part of our software development life cycle. So for that, we have secure development life cycle. It basically is it it's basically talking about software security, where we try to make the software behave correctly in the presence of malicious attack. So in the requirement phase, we talk about information gathering, like customers experience and like are the security issues being addressed. We talk about risk analysis, we identify the risk, and we also talk about threat models, about abuse cases revolving around it, how the actors can use it, and like trust boundaries and everything. In design phase, we talk about the um, we talk about the software architecture, software components, programming language, and interfaces being used. While in the implementation phases, we discuss the secure design principles. Are they being addressed or not? Um, are they being addressed or not? Like principle of least privileges, like giving only the privileges which are required, defense in depth, multiple layer of securities, and securing the weakest link. If the weakest link is like broken, like no point of having all the that security around it. So when we talk about verification, so verification is is the code, are there any code reviews being done, are there security tests are being conducted, and is this all being documented? In deployment phase, security upgrades and procedures are being followed, and Maintenance is basically the need to upgrade that with technology, and the discovered attacks are being addressed and the incidents are being reported, and like a patches and everything is being deployed. So when we talk about testing, there are like 4 types of testing: manual, which is like human review is being done, and when we talk about threat modeling, that is like abuse case and security threat actor applications might face. Source code review is manually checking the source code of the web application. Penetration testing is like tester acts like the attacker. So testing approaches, we have 3 testing approaches: static being the type of testing in which code is not executed and it can be done manually, while in dynamic the code is being in operation and it is during the runtime. While in automated testing, it is like a combination of static, dynamic, and like it is automatically done by a piece of software. In this application, it was observed that these are the vulnerabilities we found: that input data validation and sanitization were not used, revolving around the dates and data fields, while the passwords were hard-coded in the db.java file. There was missing encryption and hashing, like passwords like were in plain text, most of the sensitive information. The application was lacking role-based access control. Basically, the librarian had this privilege to create users, redundant code and unused code, multiple life of sane code, improper and mislogging, like if an entity is being deleted or created, it wasn't being logged. SQL injection was there, prepared statements were not used, select star was there because that could consume more memory, CPU utilization, and exhaust the resources. While particularly to Java, catch of generic exception, that is basically like all the exceptions are being thrown, are being catched. Access modifiers are set to public. Instead, they should be set to private because it gives and compromises the data being exposed. Classes are declared as public. They shouldn't be declared as public, while access modifiers such as public final should be used because it will again compromise and be accessible. Break of encapsulations. Well, the solution for this is basically follow the OWASP top 10 vulnerability standards, use common vulnerability and exposures database. Based on that, secure it. Use of secure principal designs, secure development lifecycle, and SDLC is king. And like, but with this, there was also an insights which was open, like as SDLC is important, so is the software design, and there were many flaws revolving around the design of the software. That's it. Thank you.